In this lesson, we're going to start talking about quadratic functions. A quadratic function is a function, let's say f, of some variable like x that has the form ax squared plus bx plus c. In introductory algebra, we often talk about this as being linear. Well, the next step up from linear is quadratic. It's where you add an x squared term. So we call this the quadratic term and this the linear term. And usually this is just referred to as some constant. We've also learned about what linear functions look like. If you have your axes, y and x, a linear function may look something like this. So what does a quadratic function look like? To think about what a quadratic function looks like, let's start by picking a really simple quadratic function. Let's say f of x is equal to just x squared. And remember that this f of x resembles your sort of y value. So here I've drawn my axes, and I've picked my scale. So let's just try picking a point. What happens when x is 0? Well, 0 squared is just 0, so your y value is also 0. So here we have a point. Now let's pick x to be 1. 1 squared is 1 times 1, which is just 1. And let's try 2 now. 2 squared is 2 times 2, which is 4. So 1, 2, 3, 4. Now at 3, 3 squared is equal to 3 times 3, which is 9. So I go all the way up to 9. And now let's look at the left half of this. Let's say negative 1. Well, negative 1 squared is the same thing as 1 squared, because a negative times a negative is a positive. So it's going to look the same. And the same goes for negative 2, because negative 2 times negative 2 is just 2 times 2, because 2 negatives make a positive. And the same goes for 3. Now if I connect my dots, I get something like that. So now that we see what a quadratic kind of looks like, what's so special about it? What different kinds of quadratics can you have? Well, to begin with, there are two major categories. So I'll just draw two little graphs here. And with what we chose, f of x equals x squared, it's pointing up. It's like opening up. Everything is above this line. So, if x squared goes up, what would negative x squared look like? Well, it would be the exact same, but all the y values would be negative what they were before. So it would look like that. So there are your two main different kinds of quadratics. This one has a minimum, and that's because the y value can go infinitely large. But the smallest it gets is an actual value. In the case of x squared, it's 0, because that's as far low as we could get. So that's a minimum. In that case, this is going to be a maximum, because there's a highest value that y can be. Y can be as high as, in that case, also 0, but it can be extremely negative. It can go as far negative as you want it to. So it has no minimum. Just like in red, there is no maximum. It just goes as large as you want it to. So what about a not so simple case? Like this one, this general case of what a quadratic looks like. How do I know what the graph will be? Well, to begin with, all quadratics have a vertex. What the vertex means is if here, let's say this is some quadratic, the vertex is this minimum or maximum. It's wherever that happens. So here I might have a different quadratic, and that's its vertex. And maybe another one with a vertex up here, or this one with a vertex up here. It's always the extreme value, whether it's as low as it gets or as high as it gets. It's a point that is very special on the quadratic. It's very special because if I gave you that point and told you it was a minimum, then you could immediately have an idea of what the quadratic looked like. So where is this vertex located? Well, there's a very special formula that you can use to find this. The formula is that the x-coordinate of the vertex of a quadratic function, as we illustrated here with a's, b's, and c's, it's going to be negative b over 2a. This is very important. Once you found this, you can then find the y value, which gives you a coordinate. And this coordinate is your vertex. So we can write this vertex as a coordinate. In this case, we know the x-coordinate is negative b over 2a. So the y-coordinate is going to be f evaluated at negative b over 2a. So if this is our vertex, this is what's called the minimum or maximum value. If I asked you what the minimum of a vertex was, or the minimum of a parabola, you would tell me the y-coordinate at that point. So we know that that point is the min and max, or min or max. The question is, which is it? Is it the minimum or the maximum? What direction does this quadratic point? Just because I have a vertex doesn't mean I have the parabola, because it can go up, or it can go down, it can be extremely steep, or it can be really narrow, or really wide. For the sake of this lesson, we're going to talk about whether it goes up or down. In other words, whether this vertex is a max or a min. And the answer all depends on this a value. Let's look at the case of my examples from earlier in this lesson. If f of x was just x squared, in other words, a is 1, b is 0, and c is 0, we knew it pointed up. And if f of x was negative x squared, that means a is negative 1, b is 0, and c is 0, and that pointed down. This gives us a hint at what significance a has on whether the quadratic has a maximum or a minimum. The answer is, if a is positive, then you have a minimum. Your quadratic goes upwards a lot. If you have a negative, then you have a maximum, meaning that your quadratic goes downwards a lot. This means that you have a minimum if a is greater than 0, positive, or a maximum if a is less than 0, negative. There's one more thing I'd like to talk about in this lesson today, and that's the axis of symmetry. The axis of symmetry says basically if you have some graph, you have a vertex, and you know it's a max or a min, the axis of symmetry is the line where it's symmetrical. I'm going to redraw it to be a little more clear. So here's a quadratic and its vertex. We know it's, in this case, a max, so that means a has to be negative. So what is the axis of symmetry? The axis of symmetry is this line, this sort of imaginary line, that everything on the left is symmetrical to what's on the right. This line is described as some x value. And I say x value because it doesn't matter what y is. It's just a line of whatever x is at. Y can be 10, y can be 100, y can be 0.1. It's just the x that matters because no matter what y is, it's at whatever x right here. So conveniently enough, you've already found the axis of symmetry. The axis of symmetry is this x-coordinate of your vertex, because whatever is on the left of that vertex is symmetrical with whatever is on the right. Lefts and rights always talk about x's. Ups and downs always talk about y's, which is why the min and max is talking about the y value, because it's up and down, while the axis of symmetry is talking about the x value. It's how far left and right, this parabola is symmetrical. I just said a word there, an important word. Parabola. A parabola is how we describe the shape of a quadratic function. While for a linear function, we had a line, for quadratic function, we have a parabola. It's really just a word used to represent the shape of a quadratic function. A lot of material was discussed in this lesson, so please check out the examples to learn more about these quadratic functions.